Hi guys, Mathmaster here, and today we're going to be trying to construct an explicit formula for the arithmetic and geometric sums. First, let's start with an arithmetic sum. So an example is, say, 5, 9, 13, 17, 21, and 25. So let's take the sum of this arithmetic sum. So first, let's flip the terms of the sequence and write it underneath it. So we have 25, 21, 17, 13, 9, and 5. And we know that these two have the same sum because we're just flipping the sum. we're flipping the terms. Okay, so now let's just take the sum of each pair, vertically. So basically, 5 plus 25 is 30, 9 plus 21 is 30, 13 plus 17 is 30, 17 plus 13 is 30, and so on. So these two are also 30. And this equals to 2 times the sum that we want to find. And so now we can find an explicit formula since all of these terms are 30. So it's 30 times however many terms were in the original sequence. So it's 30 times number of terms. And in this case, there are 6 terms. So this is 30 times 6. So if you want to find not 2 times the sum, but if you want to find the single sum, then you just have to divide by 2. So the sum would be 30 times 6 divided by 2. Okay, so now let's try and construct a general formula for this. So we have the first term a, the second term a plus d, so it has a common difference of d. The third term a plus 2d, a plus 3d, and all the way until the last term, which I guess we'll just call L. So now we just have to write this backwards, L all the way until A, and then we take the sum, which is going to be A plus L, and then that sum multiplied by the number of terms. And this equals to 2 times the sum. So if you want to find the sum, we just have to divide by 2. So we get that the sum equals to the first term plus the last term divided by 2 times the number of terms. Okay, so now if you have an arithmetic sequence and you want to find the sum, you now know how to find it. It's just the first plus the last over 2, which is basically just the average of the first and the last times the number of terms. Okay, so we got arithmetic sequences out of the way. Now let's move on to geometric sequences. So we have geometric sequence, for example, 4, 12, 36, 108, and 324. So we have to find the sum of this sequence. So for now, let's just factor out a 4, just to put it out of our way. So you get, it's 4 times 1 plus 3 plus 9 plus 27 plus 81. So let's just ignore this 4 let's just ignore this 4 and let's take this sum. So if you write everything in base 3, we get that it's 1 plus 1 0 plus 1 0 0 plus 1 0 0 0 plus 1 0 0 0 0, and then base 3. All of this is in base 3. Then we get 1 1 1 1 1 base 3. And now this may not help us. It may not appear that it will help us, but if you multiply this by 2, multiply it by 2 base 3, and we got 2 because it's the base number. It's the base minus 3, so this is 3 minus 1. So we get 2 2 2 2 2 base 3. Notice if we add a 1 base 3, this just becomes 1 0 0 0 0 0 base 3. So this sequence equals to 100,000 base 3 minus 1 base 3 divided by 2 base 3. So now we have that. You can do what we want to find. So we got that 1 plus 3 plus 9 plus 27 plus 81 equals to, if you convert this expression into base 10, it is basically 3 to the 5th minus 1 divided by, well, let's just call this 3 minus 1, because that's how we constructed it. Because if you multiply it by, say, like 3 or something else like that, then it wouldn't have the property that it's 1 less than like this special number. So now we have that, and since we can't forget about our 4 that was there, we can just multiply both sides by 4. So we have that this is our sum. And now let's generalize this a little bit. So we have the geometric sequence is A plus AR plus AR squared all the way until A times AR to the n minus 1, where n equals to the number of terms. And once again, we factor out an A, get 1 plus R squared plus R to the n minus 1. So now here, we just have to find the sum of this. And if we used what we figured out previously in our example, we see that this is 3 to the 4th. So the highest power is 3 to the 4th, and this number is 3 to the 5th. So we have to add 1 to the power. And since the power of the highest is n minus 1, this expression should be r to the n minus 1 divided by r minus 1. And then of course we can multiply by a to get our explicit sum for any geometric sequence. So these two are what we found in this video. Thank you for watching this video. I hope you enjoy. Please leave a like and subscribe to my channel, and I'll see you in the next one.